Okay, real quick, I'm going to go over the algebraic methods of solving quadratics in section P5. I'll go through it fairly quickly, but don't be afraid to stop the video and rewind and listen to it again if you need to hear it. Okay, so there's several methods. One method is factoring. So if there's a coefficient of 1 in front of the x squared, so when a is 1, it's pretty easy to do. You just look at, once you get it set equal to 0, you think of the pairs of factors of your constant, negative 14. I can do 1 and 14 or 2 and 7. I want the pair that adds up to negative 5. So that's going to be negative 7 and positive 2. So it's just going to be x plus 2, x minus 7. When I FOIL this back out, I'll get x squared, I'll get my negative 14, and my middle term will be 2x minus 7x, which is negative 5x. So to get that middle term, I'm looking at the outer product and the inner product. Once I know that I have two things that multiply to give me 0, zero product property says either x plus 2 has to equal 0 or x minus 7 has to equal 0. One of those two has to be 0. And so when I solve this, I get negative 2 and x equals 7. So if I were thinking about the graph of this, when I go to graph this, it's crossing the axis at negative 2 and at positive 7. So it's a parabola that is hitting the axis, the x-axis at those two spots. Okay, so when there's a number in front of the x squared, so when a is not a 1, it's a little bit tougher. That's when we're going to take the product of those two. So 6 times 2 is 12. I need to think of the pairs of factors of 12. So 1 and 12, 2 and 6, 3 and 4. I want the pair that adds up to negative 7. So now I'm thinking, okay, to get a positive 12, I can take a negative 3 and a negative 4. So that's the pair I'm looking for. So you rewrite this middle term, leave the first term 6x squared, but rewrite negative 7x to have those two coefficients, negative 3x minus 4x. And then you factor by grouping. Group the first two together. They have, we'll get this a little closer, they have a 3x in common. So I'm left with 2x minus 1 when I take 3x out of there. Here I'm going to take out a negative 2. And if I do that, I'm left with a positive 2x and a negative 1. And it is important that what's in the parentheses is the same. So if you take out a positive 2 from these two, you would see that you'd still have a negative 2x and a plus 1. You want it to be 2x minus 1, so that's why I took out a negative 2. So I have two terms here. Common factor is 2x minus 1, so I factor that out. In this term, what's left? If I factored out a 3x. In this term, what's left when I factor it out? A minus 2. So now I know I have 2x minus 1 is one factor, and 3x minus 2 is the other factor. Set each of those equal to 0. Here I'd add 1, divide by 2. Set this factor equal to 0. I'd add 2 and divide by 3. So there's my two roots. Okay, so two different ways of factoring. One, if there's not a coefficient in front of the x squared, it's a little bit easier. Just look at the pairs of factors of that number. You want the two that add up to the middle term. When there is a coefficient in front of the x squared, you're looking at the product of the constant and that leading coefficient. Think of the pairs of factors that add up to that middle term. Then you have to rewrite the middle term and factor by grouping. Okay? Now, the other kind of quadratic that you might see is when you have two terms. If it's going to factor with two terms, it has to be the difference of squares. So if I look at this one, 36 minus 9x squared, they're both perfect squares, and they have a minus sign. So I just draw my two sets of parentheses. How do I get 36? 6 times 6. So you're thinking what times itself gives me 36. Put a plus, put a minus, so that these are going to be conjugates of each other. And 9x squared, what times itself gives me 9x squared, 3x, and 3x. So I still get my 36. My last term is going to be negative 9x squared, but my middle terms will be 18x and negative 18x. Since they're opposites of each other, conjugates, those will go away. And then when I set each of those equal to 0, and 6 minus 3x equal to 0, here I would subtract 6 and divide by 3, so that would be negative 2. Here I would subtract 6 and divide by negative 3, and I would get x is 2. So 2 and negative 2. So really, just three things you have to know about factoring. If you have a trinomial with a being 1, if you have a trinomial with a not being 1, and then if you have a difference of squares. Okay, quadratic formula, you need to know the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You need to know that, where a, b, and c are the coefficients of x squared, x, and your constant, again, after you set it equal to 0. So in this case, I'd say x is equal to the opposite of b, so 7, plus or minus the square root of b squared, so negative 7 squared, 49, minus 4 times a times c, all over 2 times a. So x is going to equal 7 plus or minus, this will be 49 plus 12, because I have a negative times a negative. So 49 plus 12 is 61, I believe, all over 6. And that cannot be simplified. We did talk a little bit in class about simplifying. Remember, if you got an answer like 3 plus or minus the square root of 8 over 7, you have to know how to simplify radicals. So think of any perfect square, and 8 you can take out a 4, so the square root of 4 is 2. So instead of writing the square root of 8, I'm going to write it as 2 square root 2, because I can take out that square root of 4. So you're just thinking of perfect squares, anything that perfect square that goes into 8, that you can simplify that so that that kind of comes outside that radical. The other thing we talked about was simplifying. If I have something like 6 plus or minus 10 square root 5 over 12. If there's something that goes, once you've simplified this radical, if there's something that goes into all of those terms, the number in front of your radical, this number, and this number, you can simplify it. So if 2 goes into all of those, I can take a 2 out of each and write it as 3 plus or minus 5 radical 5 over 6. I just divide each of those terms by 2. So a couple different things you have to make sure you can simplify radicals. And then once you have your radical simplified, if there's something that goes into all 3 terms, it has to go into all 3, that you can take it out of there to simplify it. Okay, extracting roots. That just means if you have something that looks like this, instead of foiling everything out to solve it, you can just take the square root of both sides. Don't forget that you need to get 2 answers because it's something squared. So when you take the square root of both sides, don't forget it's plus or minus over here. So it's plus or minus 5. And then I just subtract 7. So x is going to equal positive 5 minus 7, negative 2. Or x is going to equal negative 5 minus 7, negative 12, to get my 2 answers. So that's what we mean by extracting roots. Okay, and then on the back, completing the square. The steps to completing the square is the first thing we need to get that 5 over on the other side. You kind of get the constant over here. I add 5 to both sides. You have to get rid of that leading coefficient, so I need to divide every term by 2. And I usually just leave it as a fraction over on this side, so divide every term by 2. Then, to complete the square, you take half of this. Half of 5 is 5 halves. Square it. 5 halves times 5 halves is 25 fourths. So if I add it over here, I have to add it over here. You are always going to be adding something, not subtracting. This now is a perfect square. It's x plus 5 halves squared. And again, if you try to multiply that out, multiply it by itself, you will get those 3 terms. Over here, I get, change this to fourths, so I multiply by 2 over 2. I get 10 fourths plus 25 fourths is 35 fourths. And then I extract the roots by taking the square root of both sides, like we just did, plus or minus on this side. When I take the square root of that fraction, I can take the square root of the numerator over the square root of the denominator, which is 2, and I subtract 5 halves. So I'll have a negative 5 halves plus or minus the square root of 35 halves, and since they both have a denominator of 2, I can just write negative 5 plus square root of 35 in the numerator, all over 2 and put them together. So that was kind of quickly the steps of completing the square. Get the constant on this side, divide by your leading coefficient. To complete the square, you take half of your x coefficient squared, add it to both sides. Write this as a perfect square. It does always factor into a perfect square, and then extract the roots by taking the square root of both sides. Okay, so that's the different ways of solving equations algebraically.